Good morning, class. I wanted to make a video for notes for Monday 9:20 or Tuesday 9:21, especially because Tuesday I am in a training, and so I want to make sure you have these notes. The good news is this is review, these notes. It is preparing us to do inequalities within our absolute value equations. But before we do that, I wanted to make sure we review how to do regular inequalities, okay? And then a few new ways to write them. And so when we're talking about inequalities, we're talking about x is less than or equal to, or x is greater than or equal to, or x is less than. So there's different ways that we're talking about this, and it's going to include more than one number. And so when we use this on a graph, you're going to see an open dot when we're not including something. And so if we're not including a number, you'll have an open dot right here. Okay, you'll have an open dot, meaning it'll be hollow. And the symbols will not have that equal sign underneath. Okay. Now, if the dot is closed or solid, right, then you will have that little equal sign on the bottom, okay? So that's just remembering how we come up with, is there an equal sign underneath or not, okay? Now, one way to write these, and this is a little different, is called interval notation. Now, notation is the one that we're going to be using from now on. This is an Algebra 2 or a higher math way to write inequalities. And so instead of having to use necessarily the symbols here, we can use parentheses and brackets. And so we will be still using the infinity symbol, we'll be using parentheses, and we'll be using brackets from now on. When you see a parenthesis, that means it's not included. So it's like my green up here. It was an open dot and it was not included. We'll be using a parenthesis when something is not included. When something is included, like my pink up here, then we're going to use brackets. Brackets will indicate that something was closed and we're including it in the inequality. So let's do number 1, for example. So let's say 8 is here, okay? And in this case, number 1 is telling us that x is greater than or equal to 8. So on the number line, we know because there's this equal part underneath, we're going to have a closed or solid dot, okay? From that, we know that x is going to be greater than. So we know that that means we're going over here to the right. It's going to be greater than. So normally the way we would write this, we would have 8, and then we'd have x is greater than or equal to, and then we would have infinity, plus infinity, okay? Instead of writing it this way though, we want to use interval notation. And so now the 8 is going to be included, so it's going to have a bracket, and then we have a comma, and the other side was infinity. Now, infinity is never included. It will always have a parenthesis. And so this is now a new way that we can write it without having to use the inequality symbols. Okay, go ahead and pause, and I want you to try number 2 on your own. Okay, so hopefully you got a picture like this, where you had at -1, you had an open circle because there's no equal sign underneath this. So we're having an open dot. And this time it says A is less than -1. So our arrow is going to be going on the negative direction towards the left. So our interval notation then is the left side will be a parenthesis, and that'll be infinity. And then comma, the right side is -1. However, that is also a parenthesis because it's not included. And so that would be the answer. That tells me that I'm going from negative infinity, it's even better to have a little negative here, negative infinity to negative 1, but we're not including negative 1, okay? So when we start having to solve these, in number 1 and number 2, they were already set up where the variable was alone. We're going to have to start solving these to get the variable alone. And when we do that, there's a few rules that we have to remember. So to follow some of the rules of inequalities, if the inequality is multiplied or divided by a negative, then we have to flip the symbol, okay? So we're going to flip the symbol if the inequality symbol, we're going to flip it if you multiply or divide by a negative number, okay? Let's do number 3 first. So number 3, I am trying to get the V's on the same side and a number on the other side. So I'm going to subtract 5V from both sides first. When I do that, this cancels and I get 1. I have not divided or multiplied by a negative. Subtraction doesn't count. So I'm going to keep my sign this way. 7V minus 5V is 2V. We still have the negative 17. Then we're going to add 17 to both sides because we're trying to get V alone. So negative 17 plus 17, that goes away. Over here, I now have 1 plus 17. That's 18. And 18 is going to be greater than 2V. We still want V alone, so we're going to divide both sides by 2. We are dividing by a positive, so we do not need to flip the sign. 18 divided by 2 is 9. 2 divided by 2 is 1, so that goes away. So we get V is less than 9. Okay, so let's just say our 9 was way over here. We are not including, there's no bar under our inequality. So at 9, I have an open circle. And we are saying that V is less than 9. And so we know we're going to be going to the left. If I want to write this as an interval notation, my left side is my negative infinity. And infinity always has a parenthesis, comma, 9. And this was not included, and so it also has a parenthesis. Go ahead and pause the video and try number 4. Okay, so number 4 is a little different. We're first going to need to distribute this negative 3 to the 5x and the 9. And so when that happens, we still have this 21x here. We're now going to get a negative 15x minus 27. And then we still have the 7 on the right. From there, we can actually combine like terms. And so we are going to combine this 21x and minus 15x. That will give me 6x. Okay. We then still have 6x minus 27 on the left and 7 on the right. Now we're going to add 27 to both sides. And so we get 6x is greater than or equal to 34. Divide both sides by 6. I am not multiplying or dividing by a negative, so my sign will stay the same. And so 34 over 6 is not perfect, but I can reduce it by 2. So 34 divided by 2 is 17. 6 divided by 2 is 3. This is roughly 5.33. And so when we were to graph this, if we would say that 5 was here, then we're a little bit greater than 5. We are including, so it's going to be a solid dot. And then we're saying x is greater than or equal to that. And so we're going to be going this way. Okay. I like that we leave it in fraction form though, because it is more exact and more precise. And so when we write our interval notation now, we are including this part. So when we include something, we're going to use the bracket. and we will use 17 over 3 as our point, comma, positive infinity. And infinity always has a parenthesis. And so that's how we would write this in interval notation. Okay, there are a few more practice ones. I'll put those on Google Classroom so that you can see them, but I do want to move on to the next part. So all these practices, I will put some answer keys on there so you can see more if you would like some more. So there is something called set notation. Set notation is just another way to write the exact same information. And so, for example, here they're giving us x is greater than 5. And so if we were to write that as our new way, right, in our interval notation, we would say, okay, x is greater than 5. X is greater than 5. So we have a parenthesis because 5 is not included. And then I have plus infinity. Okay, and I can't write an infinity, so I'm going to use the pen. And that will be a parenthesis as well. Okay, so that would be interval notation. Set notation is very similar to the inequality notation, except now we have kind of these fancy brackets that go with it. And so for set notation, you're going to use this fancy bracket. And then we're talking about the x value. And so for the set notation, we like to have the variable first that we're talking about so that people know, are we talking about x or are we talking about y? So in this case, we're talking about x. So we're going to put an x here, and then we're going to put a line to separate it. And then you're going to write it the way that you used to write it with inequality notation. So in this case, we had 5, and then we had is less than, or x is greater than 5. And then it goes to positive infinity, right? And then you end the kind of fancy little bracket. And so this is the way we write this. And so the way we read it is x such as 5 is less than x less than positive infinity. Okay. We don't use this notation as much. We definitely like interval notation more, but it is good to know the 3 different ways to write it. Okay, so the 3 different ways are now the inequality form, which you've learned in the past, the interval notation, which is the one we'll be using more and more, and then this is called set notation. And so you'll notice set notation is very similar to inequality. The only difference is it's got the fancy brackets and it defines the variable ahead of time. That's the only difference, okay? So let's move on to compound inequalities. So compound inequalities are when there's going to be more than one, okay? And so if we look at this first type 1 is an OR situation. And so it's an OR situation because they're not overlapping. So you'll notice that there's this blank spot in between the two, okay? And so because there's that blank spot, it's going to be this inequality or this inequality, okay? Okay, so type 1 is OR. This is written as x is less than or equal to -4, or x is greater than 1. If we were to write this in interval notation, so remember interval notation is our new one, we are going from left to right. So to start with the left side, we have negative infinity. And so negative infinity has a parenthesis because it's not included, comma, -4 is a stopping point. And -4 is included, and so we get the bracket. And then our or sign in math is a U. Okay, it stands for union, but it is our or symbol. And then we're going to start with the next piece. So my stopping point here was 1. It is not included, so it's a parenthesis, comma, positive infinity. And again, infinity is not included, so that's also a parenthesis. So this is how you would write this or statement. It has negative infinity to -4. We know -4 is included because we have a bracket. This is or symbol, or 1, but 1 is not included, to positive infinity. And so that lets us know that in between right here is not included. It's this or this. Okay? Go ahead and solve for these two separately. So first, treat it as two separate problems. Do this one first and then this one. And go ahead and graph the or statement. Go ahead and pause, and I'm going to do that real quick. Pause. Okay, so hopefully you started to isolate x on this side. So you would have needed to subtract 4 from both sides. Then you get 3x is less than or equal to 6. Divide both sides by 3. We're dividing by a positive, so we do not need to flip the sign. X is less than or equal to 2. So I'm going to graph that. 2 is included because we have this equal sign on the bottom. So I have a solid dot at 2. And then I know that it's going less than 2. So I drew my arrow this way. So that was your first inequality. And then you needed to solve the second one. So the second one over here was an or. We needed to divide both sides by 5 so we can get x alone. 5 divided by 5 is x. We divided by a positive so the sign does not flip. And then x is going to be greater than 45 divided by 5 is 9. And so this is our second one. And so over here, 9 is not included, so it's an open circle. And we're going to go 9 is greater than, right? X is greater than 9. So we went to the right. So this is an or situation because we have one or the other. It's not including anything together. And so if we write this as an interval notation, on this side, we have negative infinity. Again, negative infinity is going to be a parenthesis. And then comma, where do we end? We end at 2. 2 is included, so it's going to be a bracket. And then it's an or situation, so it's going to have that U here for or. We are not including 9, so it is a parenthesis. And then we're going to positive infinity. And remember, infinity is also not included, so it's a parenthesis. And so that's how we would write that. Okay, I'm going to post some more examples on Google Classroom. So if you wanted to try some more of these examples, go ahead and do that and then go check your answers later. Okay, let's move on to and. So and is a little different. And is written as they're sharing a spot. Okay, and so because they're sharing it, the solution, the inequality is going to fall between two endpoints. And so we could write two statements for this if you know where it stops and where it starts, but really it's got one because it's an and situation. And so there is a symbol for and. It's an upside down U. Okay, it kind of looks like an N in the word and. And so that is the symbol for and. So you could write it just like we did where we had one of the inequalities and we had the other one, right? However, because they're sharing it, it is a lot of times just more simple to write one notation. So in this case, at -2, we're including -2. and then we're going all the way to 5. We're not including 5, however. So it's going to be like this. And so it almost becomes a regular inequality that we did at the beginning, where you don't have to use the and symbol. Okay. Go ahead and for number 7, I want you to try and isolate your x's first. So go ahead and pause the video. Try and isolate these and graph them, and let's see how you do. Okay, so hopefully you were able to solve both of these. So first over here, you're going to subtract 3 from both sides. And so you get 2x is greater than negative 12. Divide both sides by 2. We're dividing by a positive, so we don't have to flip the sign. X is greater than negative 6. Okay, so if we go to negative 6, it's going to be an open circle because it's not included. And now we say, okay, x is greater than. So we know we're going this way. Okay. Then let's solve the other one. So the other one was we needed to add 2 to both sides. So then we get 8x is less than 32. Divide both sides by 8. Again, we're dividing by a positive, so we can leave the sign. We don't have to flip it. X is less than 4. It is also not included, so it's going to be an open circle. And I know that it's going to be less than. Okay? It's an and situation. And so we want to make sure we're only including the parts that overlap. So even though this pink one technically is still going, and this purple one is technically still going this way, because it's an and situation, it's this and this, meaning they have to overlap. And so the only part we care about is where they overlap, which is right here in the green. And so since that's where they overlap, that's the and statement. Now, if it was an or statement, you could write it all out. You would write the whole pink part and the whole purple part out. But because it's an and situation, it has to be this and this. Okay? So the way we're going to write this in interval notation is the 2 endpoints, right? And so our endpoint here is negative 6. It is not included, so it is a parenthesis, negative 6, comma, and then our other endpoint is 4, and that is also not included. And so because we only care about the shared area, that's all we have to write there. Again, if it was an or situation, then we would want all the pink area and all the purple area. But for an and situation, we only care about where it overlaps. It has to be this and this, okay? It kind of goes back to math when we used to do Venn diagrams, right? So if we had a Venn diagram here and a Venn diagram here, and let's say we were talking about cats and dogs, right? So the question is, who has a cat in the class? And so let's say a certain amount of people have a cat, right? We've got 1, 2, 3 people that have a cat. And then we have some people that have a dog. Well, do we have some people that have both, right? And so let's say there's just 2 people that have both. So the first statement is, do you have a cat or a dog? That would be the separated parts, right? You have a cat or a dog. So we really don't care if you have both. We care, do you have one or the other? And so really all these people would be included. The only people that wouldn't be included are the people outside the Venn diagram that don't have any, right? So maybe there's some people that don't have any. Okay. With an and situation, they have to be shared. And so for an and inequality, it's the same idea. This green area has to be shared. So who has a cat and a dog, right? That's this middle area here. And so that was 2 people. It's the same idea here. Can we include this and this? And so that's why we care about the shaded part in between. Okay. So go ahead and practice a few of these. Again, I'm going to put the answer key up so that you can go and double check them. One of the big things that I want to remind you before I leave is, again, if you multiply or divide by a negative number, when that process happens, you need to flip the inequality sign. So if it was facing left and you divided by a negative, it's now going to face right. Okay. Other than that, please practice, and we will continue this next class by adding absolute value. Thanks, and I'll talk to you later.